All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to look at how to graph linear equations in any form. Before we were looking at just slope-intercept form, and we touched a little bit on how to manipulate equations in standard form, but today we're going to look at equations in any form. So let's dive into this. In the first problem, we are asked to find the slope in y-intercept given 3x plus 4y equals 12. All right, so because this is in standard form, ax plus by equals c, we have to do some surgery on this before it looks like an equation that we understand what to do with. So let's take the equation, 3x plus 4y equals 12, and let's write it down. Okay, at this point we need to subtract 3x from both sides. And remember on the right here, 12 and negative 3x, they don't go together. So we just write 4y equals negative 3x plus 12. And then to get y by itself, we divide each term by 4. And that cancels the 4's, and we are left with y by itself. Y equals negative 3/4 x plus 12 over 4 is 3, so plus 3. And this is an equation in slope-intercept form. This is something we can read our values right off of and also use it to graph. So the slope is negative 3/4. The reason we're able to read the values off is because now this is in slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. So the y-intercept would be 3. And we can plot the y-intercept in at 0, 3. And because we don't have another value to work with, we can use rise over run, or in this case, because it's a negative slope, fall over run. So we go down 3 over 4 to the right. So down 3, 1, 2, 3, over 4 to the right, 1, 2, 3, 4. And, you know, just as a coincidence here, this point I'm plotting is also the x-intercept because it's on the x-axis. So this is the y-int, and this is the x-int. Okay, so this is 0, 3 for the y-intercept, and the x-intercept is 4, 0. So we get those points plotted in, and then we'll draw in our line, passing through those 2 points. So we have a negative slope on our hands, and this is y equals negative 3/4 x plus 3. And that's number 1. Number 2, find, write, and graph a linear equation given this table. Alrighty. Step 1 is to compute the difference between each of the values on both the x and the y side of things. So we draw little alligators, and between this x it's plus 3, and then plus 6, and then plus 3. From 0 to 3 it's 3, from 3 to 9 it's 6, and from 9 to 12 it's 3. Down here on the y, from 4 to 3 that's minus 1. From 3 to 1 that's minus 2. And from 1 to 0 that's minus 1. And so remember that m can be expressed as the change in y over the change in x. So if we try out these ratios, that would be negative 1 over 3, and this would be negative 2 over 6, which can be reduced to negative 1 over 3. Remember, we're looking to make sure they're all the same, and then the last one, negative 1 over 3. So they're all the same. And because they're all the same, we can be certain that -1/3 is in fact the slope. Okay, so somewhere we're going to write equals -1/3. Okay, we need that. We can identify the y-intercept off the table. Wherever x is 0, that's the y-intercept, so the y-intercept is 4. b equals 4. So to write the equation in y equals mx plus b, we just take y equals, and then put the slope in as -1/3, put an x, plus 4. And now we can box this up and graph it by looking at the y-axis and putting a dot at +4. 1, 2, 3, 4. Put a dot there. And this is the y-int. And then the x, or the next point, will be down 1 over 3 to the right. So, because it's fall 1, run 3. So down 1, 3 to the right puts me right here for my second point. Right there. Okay, so now I have 2 points, and I can draw in a line passing through those 2 points like that. Okay, and the equation for that line is y equals -1/3 x plus 4. And the coordinates of that y-intercept, the coordinates of that y-intercept are 0, 4. Okay, we're done with number 2, and we'll move on to number 3. Okay, number 3, we're asked to simplify and graph square root of 18 over square root of 2, x equals y. Well, let's forget about the x and the y for just a minute and focus in on the square roots, because that's kind of the scary thing, isn't it? All we have to do here is prime factor. So let's take 18 and prime factor it. That would be 2 times 9, and 9 would be 3 times 3. Now, it's important to note that we can write the prime factors as 2 times 3 times 3. That's called the product of the primes. But using our exponent rules, we can simplify this a little bit and say 2 times 3 squared. 3 times 3 is 3 squared. That's going to be helpful for us because we have the square root of 18, right? We can rewrite that as the square root of this adjusted product of primes thing, square root of 2 times 3 squared. And then we can break up that square root. Rules of square roots allow us to break up the square root like this. Square root of 2 times the square root of 3 squared. This only works when you're multiplying inside the square root. And now we notice that we have something squared under the square root. I can't do anything else with square root of 2. It just has to stay square root of 2. But the square root of 3 square root of 3 squared just becomes 3. So it's square root of 2 times 3. We're ignoring the negative roots. So remember, we can't do anything with square root of 2. So we're going to be able to simplify this now. And we'll just rewrite everything. I'm going to put the y on the left side for clarity. Y equals the square root of 18 over the square root of 2x. And we want to simplify that. Well, we're just going to substitute down here the square root of 2 times 3 for 18 because the square root of 18 equals the square root of 2 times 3. So when I rewrite this, I'll write y equals square root of 2 times 3 all over square root of 2 and then x off to the right. Now those square root of 2's will cancel, leaving behind 3 and x. So y, the simplified formula now, equation is y equals 3x. And that's something we can plot. Remember, y equals mx plus b, there's an unwritten plus 0. So the y-intercept, let's see, write this out. The slope m is 3, so rise 3, run 1. And the y-intercept b, that's 0. Okay, in other words, the y-intercept is at the origin. So we plot that point at the origin. And then we go up 3 over 1, up 1, up 2, up 3 over 1. Plot our second point. And now we can draw a line passing through those 2 points and through the origin. And we can write this as y equals 3x. And so that's what that simplifies to. If you know your rules of exponents, it's fairly straightforward. Number 4, y equals 5x minus 50 over 2x minus 20. This is rational simplification. And we call this factoring, but you might know it better as reverse distribution. What we need to do, put parentheses around both the numerator and denominator, and then factor out the greatest common factor of both terms inside the parentheses. We do that on the top and we do that on the bottom. Okay, that's called factoring or reverse distribution. So what's the biggest number I can pull out of both terms on the top? Well, that would be 5, right? I could divide out a 5 from both terms. And so let me rewrite this. Y equals, and then the factored form would be 5 open parentheses, 5x divided by 5 is x, minus 50 divided by 5 is 10, over, now I can pull out a 2 from the bottom here, 2 open parentheses, 2x divided by 2 is x, okay, minus 20 divided by 2 is 10. Okay, and once again we have a situation where we can cancel out this parenthetical term, leaving behind y equals 5 over 2. There's no x term. Okay, so we got to turn 5 over 2 into a mixed fraction, and that would be 2.5. Well, that's just 2.5. And I graph that. There's no slope. I mean, so it's a slope of 0, right? I should write m equals 0 here. So what I do now is find 2.5 on the y-axis, and that would be about right here. And I just draw a line through it, right there. Okay, and the y-intercept would be 2.5. Okay, that would be 0, 2.5. And the equation itself is just y equals, okay, 5 over 2, or 2.5. And that's number 4. Moving on to number 5. Solve for x and graph. Okay, so we're going to be graphing only x now. It's going to be a perfectly vertical line with an undefined slope. But here we're going to apply the distributive rule and say 5 times 8x, well that's 40x. 5 times 1 plus 5 equals 125. Now to get x by itself, I subtract 5 from both sides. And I now have 40x equals 120. To get x by itself, I divide both sides by 40. And I can simplify, cancel those zeros, and I see I have x equals 12 over 4. 12 divided by 4 is 3, so x equals 3. Now the way I graph this is I just go to the x-axis and find where 3 is and draw in a vertical line passing through 3 on the x-axis. So this is really the x-intercept. X-int at 3, 0. The equation for the line is x equals 3. And that's number 5. Number 6. Find the slope in y-intercept and x-intercept given this strange-looking equation. This is called point-slope form, but that's something we'll learn about later. So the way you handle this is like any other problem that involves distribution. You will distribute that negative symbol through the parentheses. I mean, you could really think of it as -1. So let's write this out and get into it. So y minus 4 equals, and I'll write -1, open parentheses, x plus 5, close parentheses. So first step is to do this distribution, because we have to get rid of the parentheses first. So I'll just rewrite y minus 4 equals -1x minus 5. And I'll get y by itself by adding 4 to both sides. So I write y equals -1x, and -5 plus 4 is -1, so -1. And this is the equation in slope-intercept form. Okay, so we know the slope is -1, and the y-intercept is also -1. It wants to know the x-intercept. Remember, to find the x-intercept, we just set y equal to 0, and then solve for x. We got to rewrite the whole thing like that. And now we solve for x by adding 1 to both sides. We have 1 equals -1x. So we get x by itself by dividing both sides by -1. And on the right, these cancel. And I have x equals -1. And this is the x-int, located at -1, 0. Okay, so the x-int is -1. Let's now plot everything. So we've got a y-intercept at -1 right here, an x-intercept at -1, plot that in blue right here. Okay, I don't need to use the slope this time because I've already got 2 points, so I just need to draw a line through those 2 points. So I guess I'll use orange for this task. Draw a line passing through those 2 points, and that equation is y equals -x minus 1. Okay, and that is the warm-up. Okay, so that took 17 minutes. I will have given students 20 minutes or so in class. So if this was fast, watch it again. Make sure you understand how to do all 6 problems. So 17 minutes is not too long for 6 problems. That's about 3 minutes each. Okay, moving on. We will move on to the second page here. How to graph any linear equation. Let's fill this out. Step 1, get blank by itself or solve for blank. We're always trying to get y by itself in these linear equations. So we're solving for y. Step 2, arrange terms in blank form. And we want to get it in slope-intercept form. Step 3, identify m, well that's the slope, and b, well, that's the y-intercept. Step 4, find the blank intercept by setting blank equal to blank. Well, we're going to find the x-intercept by setting y equal to 0. You want to get in the habit of always finding the x-intercept, because that can serve as your second point, but it's also the root or the 0 of the function or equation. So step 5, write the blank and blank intercepts as blank. Well, we'll write the x and y intercepts as coordinate pairs. It's useful to write them as coordinate pairs so you know what your coordinates are of those points. So for x, it'll always be the x-intercept, 0, and for the y, it'll be 0, the y-intercept. Step 6, draw a graph. Okay, we want to draw a graph. Step 7, blank the y-intercept and x-intercept if possible. The word is plot. Plot the y-intercept and x-intercept. Step 8, blank a blank passing through blank blank. Okay, we're going to sketch a line passing through both points. So once we get both points plotted, we're going to draw a line through the 2 points because we need 2 points in order to draw a straight line. Step 9, blank all points plotted on the graph. Okay, we'll make sure we want to label all those points because we don't want to forget what they represent, especially the x and y intercepts. Step 10, blank the blank with the slope-intercept equation. Label the line. So we want to label the points, x and y-intercept for sure, and also the line itself with the equation in slope-intercept form. Okay, so let's apply these 10 steps to an example. Example, follow the 10-step process shown above to graph x plus 2 minus 2/3 y equals 0. So this is one of those equations that's not in any particular form, so we have to solve for y. Remember, that's step 1, solve for y. So we'll rewrite x plus 2 minus 2/3 y equals 0. And we want to solve for y. So let's step 1, subtract x on both sides. Okay, that gives us 2 minus 2/3 y equals negative x. Now we want to keep trying to get y by itself by subtracting 2. Remember, we can't combine anything on the right here. These are unlike terms. We have negative 2/3 y equals, put the x term up front, negative x minus 2. Okay, we're almost done. And now we have to get rid of this negative 2/3, and we do that by multiplying by the reciprocal, negative 3/2. You call this keep, flip, change. When you do this to the right side of the equation, you have more than one term on the right, so you must put it in parentheses and multiply everything by negative 3/2. And you have just created for yourself a distribution problem. But first, let's cancel these terms out. We now have y by itself, so y equals. To get the rest of this, we have to distribute multiply negative 3/2 to each term inside the parentheses. So negative 3/2 times negative x is positive 3/2x. Negative 3/2 times negative 2 is positive 6/2. Okay, so we can reduce 6/2 to just 3. So y equals 3/2 x plus 3. Put that in a box because we've now found the equation in slope-intercept form. Okay, we should identify here a couple points. M equals 3/2 and B equals 3. Now we have to find the x-int. Okay, so we've got the y-int at 3. What is the x-int? Well, to find that, we just set y equal to 0 and rewrite the equation 3/2x plus 3, and then solve for x, minus 3 on both sides. Negative 3 equals 3/2x. Now we're going to multiply by the reciprocal, which would be 2/3 on both sides. On the right side, all these fractions cancel out, and I have x by itself. And on the left side, 2 times negative 3 is negative 6/3. So here the x-intercept is just negative 2. Right, so the x-int here is negative 2. We have all the things that we need now to draw a graph. We've got 2 points, we've got a slope, we've got an equation. All right, so we need to draw a graph now. So there's no graph drawn currently, and we need to draw one. So let's draw one in here. All right. And I will be demarcating this graph in 1/4 inches. Okay, so here's 1, 2, 3, 4, 5. And I should go down on the y-axis. 1, 2, 3, 4, 5. What I'm doing is I'm hovering that transparent protractor's line underneath the 2, so it's exactly It's not off. It's right on the x-axis. And I'll do the same thing for the y-axis. Okay, so I'll mark off 1/4 inches here. 1, 2, 3, 4. 1, 2, 3, 4. Shouldn't need more than that. And now we can plot our points. So we can plot the y-intercept at +3, right here, 0, 3. And we can plot the x-intercept at -2, which should be right here, -2. So let's label these points. This is the y-int at 0, 3. And this is the x-int at -2, 0. Now we can draw a line passing through those 2 points. All right, so we've now graphed the line, and we just have to finish this off by writing the equation. Y equals 3/2x plus 3. All right, so that's everything you do for that example. And as it says here, that's all, folks. You did it. Exceptional skills in any activity only come with dedication and practice. You are each progressing very well. Keep on growing. Okay, so today, what do we learn? We learned the process for finding, drawing a graph, graphing any equation in any form. We now have the tools to do that. So we learned a 10-step process here for doing that with any equation, any linear equation. And we also completed 6 warm-up problems to get our brain working. Now these links here are important. This is a link to this video that you're watching now. Here's a link to all of this, okay, written out. And here's a link to a blank copy if you want to practice. Okay, so make sure to freeze this or screenshot it or take a picture of it with your phone. These links are also in the description and in the pinned comment. All right, I hope you found this video helpful. If you did, please give it a thumbs up, like the video, leave a comment, and make sure you subscribe to the channel and hit that notification bell so you are always alerted to new videos on this channel. Thanks.